long time, for as hard as you can, your eye is still making tiny little jerking motions in different directions, and that kind of refreshes the image on the back of your eye. It moves it around a little bit so the different parts see different things, and your brain sees this as changing information, so you don't lose all of it. But if you've ever stared at something for a really long time, you might have noticed that you tend to kind of get tunnel vision. You start fuzzing out what you see on the periphery of your vision. The reason that happens is due to the way your eye samples space. You can think of this drawing as the back of your eye seen through your pupil. So the drawing I drew earlier would be from the side, and this is from the front. So this kind of represents the density of how your eye samples space. So towards the center where you focus, your eye has a very dense sampling, so it's very sensitive to changes here. And towards the outside, it gets more and more sparse. So you have larger and larger areas of visual space that are represented by less information, essentially. You can kind of think of them as pixels, and so the resolution of your eye essentially lowers as you get away from the center of your eye. And you'll notice this if you ever try to read something, even if you're an inch or two off of the word you're trying to read, it becomes completely impossible to read it because your resolution is just too low. You can't make out what it says anymore. And because of this also, the tiny little motions that your eye makes aren't quite enough to refresh these guys out here. So although the contents of each of these guys changes with each little jump, so they're refreshed, out here, the really large areas that are all sampled by 1 pixel, essentially, they don't really change that much, so they might still be seeing the same thing, and eventually your brain starts to kind of tune them out. And that's why you get this tunnel vision effect, where you can still see pretty well in the center, but you kind of get this graying effect. So let me draw in the shadows that you expect to see. You have your optic disc here, and coming from here is a bunch of vasculature, little capillaries going around, and they tend to avoid the center of your eye, so that they don't ruin your spot where your vision is the best. So they kind of go around like this, and you have these little tiny fractured lines. So theoretically, if these shadows were to move, you would be able to see them, because they would break out of habituation, and your brain would think, that's some new information, and you would suddenly be able to perceive all these crazy lines all over your vision. And the way that you would have to do that is to get the direction of the light coming into your eye to change rapidly, so that it moves, the shadows shift a little bit back and forth, and you're essentially replicating these little tiny movements your eye makes all the time in order to keep seeing anything at all. And this is actually possible, and it's the reason I made this video. It's a really impressive effect, and I'd love for you all to try it. You're going to need an index card or your finger if you do it just right. What you're going to do is poke a tiny hole in an index card, just a pin or the head of a pen, anything, or use your finger and make a tiny hole like this, right? And you're going to hold it up in front of one of your eyes, close the other eye, and look at a bright surface. You can look at a computer monitor or something that's just blank. Some white paper should do just fine. And you're going to hold it up to your eye, remember to close your other eye, and look through it and shake it back and forth about that fast. You're going to want to shake it so that the hole moves less than the diameter of the hole itself. So you don't want to be going like that. You want to just move it so that you have some spot that you can always see, but the hole itself is generally moving. So what you're essentially doing is making a source of point light that's moving back and forth in front of your eye, and it should change where the shadows land on the back of your retina. And if you do it just right, and you're looking at something nice and bright and blank, you should see this little network of lines. There'll be kind of a light gray, like spider-webby texture across everything. And remember that since you're moving it this way, the light is going to move like that, and you're only going to see things that are aligned in this direction. Because if you have a shadow this way, and you're moving the light back and forth this way, the shadow will move up and down, but it'll still make the same shadow locally, so your eye won't notice a difference. So what you can do is move in little circles to get the best visibility, and you'll theoretically be able to see things at all different angles. And that's how, thanks to the fact that your retina is inverted, just using a light source, a tiny pinhole, and a little bit of science, you can see the vasculature at the back of your own eye. And I think that's pretty freaking awesome. I hope you enjoyed it. Let me know if it doesn't work for you, and I can try to help you sort out what you're doing wrong.